Hi all, welcome to our deep learning series. My name is Rajagopal. In this video, we are going to see positive and negative of derivative. So, because positive and negative of derivative is very important in neural networks. So we will see what is the impact of positive and negative of derivatives and what is positive and negative of derivatives. Okay. First, we will take a function f of x equal to x sine x square plus 1. So in this function, if you plot a function and in a graph, we will get this kind of a non-linear plot. A non-linear plot, we can get a non-linear plot. And by using this plot, we are going to see what will be the derivative be positive and what will be the derivative be negative and when will the derivative be 0. Okay, so all three conditions we are going to see. And so if you simply consider, so if you take this model into our neural network, so we can consider x is our weights. Okay, so x is our weights and f of x is the error function. Okay, f of x is the error function or loss function. So now we have to get that weight. Okay, whenever we have to find our weight value when our error is minimum. Okay, so when our error is minimum, here we can see. Okay, so in this plot we can see here our value is what I say our error is so minimum. So here almost reach the zero. Okay, here almost reach the zero. So our is so here the maximum. Okay, here the errors are the maximum values. Okay, so now what we have to see uh, now we have to see what is that positive and negative of derivative. Okay, so whenever our derivative, so this is the first we will see. Okay, so if you draw a line, okay, if you draw a line in this direction, so parallel to these kind of lines give the positive slopes. Okay, positive slopes, these kind of lines. Okay, so these are the positive slope lines. Okay, so these are the positive slope lines. So if you do slight increment in x, okay, so automatically it will increase the y direction also. Okay, so if you increase in x, okay, so automatically y also increasing. Okay, so y also increasing. Okay, so these kind of lines are positive slope lines. Okay, so next one is the negative slope lines. Okay, next we will see a negative slope lines. Okay, these direction lines. Okay, these direction lines are negative slope lines. So here if you increasing our x, okay, if you increasing our x, so y value is increasing. Okay, here we can see whenever we are increasing our x value, automatically y value is going increasing. Whenever we are reaching our maximum x value, almost y value equal to 0. Okay, so these direction lines are called the negative slopes lines. Okay, so negative slopes lines, so these are the positive slope lines. Okay, so now we have to reach these minimum error. So this is 0 error, so other let me consider this our minimum error. Okay, this is our minimum error. So here what we will do, we will usually, so we will increase our, so we will change our weight value. Okay, we will change our, so every epoch we will change our weight to a slight increment. Okay, slight increment, that is a landing rate 0.007. Now we have to know which direction we have to increase our weight. So whether we have to increase in a positive direction, whether we have to increase our negative direction, that is purely depend upon this slope. Okay, this is the slope of the our function. Okay, slope of our function. So if you have the our, so if you see this line, okay, this line is parallel to, okay, this line is parallel to, so this line is parallel to positive. Okay, so if you see this line is parallel to positive. So here what we can do, so here our, this is our positive slope. Okay, so whenever we have positive slope, so if you increase x, okay, if you find a positive slope, if you increasing our x, okay, our y also increasing, so the error also increasing. So what we have to do, so whenever we have the positive slope, we have to decrease our x, or we have to decrease our weight, okay. So or we are we have to decrease our weight, okay, we have to decrease our weights, okay, we have to decrease our weights, then we will reach the minimum value, okay. So this is the opposite direction, so this is the ultimate, so automatically this is the opposite direction. So this is the negative slope. So whenever we are getting a negative slope, okay, whenever we are getting a negative slope, what we have to do, we have to increase our x, okay. So what we have to increase our x, okay. So automatically we will moving down to the minimum error value. So this is the concept behind that positive and negative of derivative. So by using the positive and negative of derivative, we can get the minimum, okay, we will get the minimum error at the particular weights, okay, particular weights. So we can, so this is our finalized weights by using the weights. So our model will give a better result, okay. Thank you, we will see the next video.